What is up, guys? Another day, another Leetcode. I know you guys aren't tired of hearing my ASMR voice, but without further ado, let us tackle another problem. All right, what do we got today? Merge a sorted array. All right, how hard could it be? And then it ends up being a fucking 2-hour fucking journey. Okay, let's go into this. Merge sorted array, cool. You're given two integer arrays, nums1, nums2, sorted in non-decreasing order. Non-decreasing means it's not necessarily increasing, but it never decreases. So you can have 1, 2, 3, 4, 5. That's an increasing array, right? Non-decreasing means it could be 1, 2, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 5, 6, 7, 8, 8, 8, 8, 8. Because it's not decreasing, but it plateaus. You can have plateaus. So, given two integer arrays sorted in non-decreasing order, and two integers, m and n, okay, representing the number of elements in nums1 and nums2, merge nums1 and nums2 in a merge nums1 and nums2 into a single sorted in non-decreasing order. Okay. What? Okay, so the final sorted array should not be returned by the function, but instead be stored inside the array nums1. To accommodate this, nums1 has a length of m plus n, where the first m elements denote the number of elements that should be merged, and the last n elements are set to 0 and should be ignored. Okay. Nums2 has a length of n. Okay, so basically what we're doing is we have an array that's bigger than it should be, one of them, and the other one is just an array. Both of them are non-decreasing order, except the one that's bigger has a bunch of zeros at the end, tailing, and that's supposed to be where the space is supposed to fill up. Okay. So what's the easiest way I can do this? So let's take a look at the example first so I don't get fucking dogged by the requirements, right? The requirements are important for a reason, because they could either make or break your solution. I could have the best solution in the world, but the requirements say, let's say for example, like paint me a car, right? And I paint it red. I painted the car according to the solution, but the requirements in the fine print says you can't use the color red, right? So I get fucked because I spent all this money painting it red, right? So always double back on your requirements, because that's where all the value of the solution lies. I love this water bottle, by the way. It's awesome. I'm not sponsored by them, but I just love the quality of it. Nums1, nums2, okay. Okay. So we look at nums1. There's 1, 2, 3 and a bunch of zeros. 3. M equals 3. Okay. Nums2. N equals 3. Okay. The output is the sorted array. Okay, cool. The arrays we are merging are 1, 2, 3, and 2, 5, 6. The arrays we are merging are 1, 2, 3, and 2, 5, 6. The result of the merge is 1, 2, 3, 5, 6 with the underlined elements. coming from nums 1. Okay. 1, 2, 3, 4, 5, 6. Okay. Nums 1 length is n plus n. Nums 2 length is n. Okay. 0 to m, n is less than 200. Okay, so non-decreasing, so they're all positive numbers. M plus n is, so we have at minimum 1 and n. Okay, length of n. Okay, so what I'm gonna do here, so I have a 0 case here. So if n equals, if length of n equals 0, return nums 1. Okay, the next thing I'm going to do is I have the index, so m. I want to use m as my index for the last number that I want to check. See what I'm saying? M and n are just lengths. So 2 integers, m numbers, number of elements in 1, number of elements in 2 respectively. So m is not the actual number of elements. N is the actual number of elements, right? So m, nums 1 has a length. So nums 1 is always the bigger one. So knowing that, we can use m as the index of the last number for nums 1. And then for nums 2, what we can do is, because we know the length of n, we could just swap all the zeros of nums 1 with n, and then just use the built-in function to sort it. So what I'm going to do is for nums for 0. I'm going to call it 0 because I want to target the 0 values of nums 1. So 0 in range. So it's going to be 0, 1, 2. 0 and 2, because m is 3, so it's going to be m minus 1, 2, because it's not always going to be 3, right? I'm just using 3 from the example to make it work, but no matter what n is, it's minus 1 to give you the index. So m minus 1 up until len nums 1, because this already contains the full length, so I could just go length, and it's non-inclusive, so it goes to the last one minus 1 anyways. So I go here, so for the zeros, starting at m minus 1, so 0, 1, 2, 0, 1, 2, m minus 1, 0, 1, 2, oh no, it's actually the m, because 0, 1, 2 is 0, 0, 1, 2, 3. See that? So I'm just going to start at m, because this is the number of elements that are non-zero. So it's going to be 0, 1, 2. These are the indexes, but I want to start at 3 for where I swap. So I just start at m. Next, I want to go through so for 0 in m. Okay, so yeah. And then I also have to keep track of n. So n, I'm going to say n equals no. I want to stop when n is, what's it called? I want to stop when n reaches the end of its array. So I gotta go 0. I could either put a counter here, actually, but it's gonna keep going, so I just have to keep track of n at 0. So nums2, and n. Okay, let's write out the logic first. So range is going to be nums1, the first 0. It's going to start at m. Actually, so you guys don't get confused, I'll just make this I. So for I in range thing, so the index at m is going to be, for example, 3. 0, 1, 2, 3. That's going to be 0. And then I'm going to make that equal to n. Let's put counter. Equals 0, nums2, counter. And counter plus plus, or plus equals 1. That way we go to the next index for the next item. So counter plus equals 1, and then we fill it up. And then I go, now we're outside of the array, so nums1 dot sort, return nums1. Run. That should be it. What the freak if len n equals 0? Object of type int. Oh, because n is an integer. I could just put if n equals 0. If n equals 0. Or I could put length of nums2. See? So really quick walkthrough again. I saw the base case here, so it said if there's a 0 array for n, then I could just return nums1 as is, right? Because nums1 just has the array 1, and they just return that. So if there's nothing in the second array, I just return the first array as it is, because it has no extra allocated space. Because nums1, if we look at the requirements, is m plus n. Right, so m is the length of what it's already at. So it could have been 1, 2, 3. But since there's no n, we know there's no tailing zeros. So we just return nums1 as is. The second part is we want to make sure that we use the same nums1, because we're not producing a new array. So I'm not going nums1 plus nums2 and then sorting it. No, because nums1 already contains the space to add nums2. So this array, the first one, has enough space to accommodate the second one. So that's why if you look at this example here highlighted, in example 1, n equals 3, and there's 3 extra zeros in nums1. So I gotta fill up those zeros. So what I do in my loop is I start the loop at the first 0. And then I fill it up with the corresponding elements in n. So in nums2, from 0 to the end. So it's like, okay, the first 0 is the first element of this array. Second 0 is the second element of this array. The third 0 is the third element of this array. You see what I'm doing here? So that's why I start at range m, because m is 3. I have 1, 2, 3 elements, but the array index is 0 index. So this 3 elements is 0, 1, 2 in the array. So the element after that, the first 0 is 3. So I just leave m as is. So what I do here is I started at I, so I equals m. So the first 0 is equal to the counter. And I made a counter variable so I can trace the first element of the array. And as I keep adding, I go to the second element of the array, third element. So the counter goes up every iteration of the loop. So I go counter plus 1 after I add the 0th element. Now it's going to 5 because it's counter 1. I add the 5. Now it's counter 2. I add the 6. So once I'm done, my nums1 array is now full, but it's not sorted. So I just take advantage of the built-in sort function that Python has. So if you can see here, the requirements don't say we can't use any built-in functions. See that? There's a follow-up. Can you do it in O m plus n time? We could, but it doesn't say that we can't use built-in. So if me being trying to solve this the easiest way I can, just use the built-in function. Now that I have the built-in function, I just sort it because it's full. The nums1 array is full with nums2 at the end, so I have to sort it to make sure it's in non-decreasing order. So once I sort it, I just return the sorted array and I'm done. So let's submit it. Boom, beats 94.11%. So we could go through the array. So it's not going to be O of n plus m, but it's going to be O of n log n because I use the built-in sort function, and that sort function's time is n log n. For space complexity, it's just going to be O of 1 because all I'm storing is a counter variable. There's nothing else that I'm actually storing and scaling over time. Nothing actually increases in space. It's always going to be the constant counter at one element that changes. So we solved that problem the easiest way possible, and yeah, it beats like pretty much everyone that was solving it, like 94% of people that tried solving this problem. So if you liked the video, give it a thumbs up. If you have any advice, any criticisms, just anything in general, put it in the comment section. I'll take a look at it. I read every single comment. And yeah, don't forget to subscribe to the channel because I'll be producing more of these and I'll get more efficient and I'll show you guys some tricks. I'll pull out the whiteboard sometimes, So stay consistent and happy coding. Knologist out.